Good morning. Thank you for starting your day with us here. I'm Mara Diaz. I lead the Clean Water Initiative for the Surfrider Foundation. What I'm going to be talking about today is the experience of our chapter on Maui, leveraging the community partners that they established through their volunteer water quality monitoring program to assess human health risks following the Lahaina wildfires. Quick introduction. We are a nonprofit grassroots organization. Our mission is to protect and enjoy our ocean waves and beaches. We're people who love the beach. We're people who love the ocean, and we're willing to volunteer our time to protect it for our own use and for future generations. We have this shared vision of clean and healthy beaches for all people, always. And one of the programs that we run in order to move towards and meet this mission is our Blue Water Task Force Volunteer Water Quality Monitoring Program. With this program, we have over 60 labs currently in operation run by volunteers across the country. We hit a benchmark of collecting over 10,000 tests or water samples last year. So this is a program that has just grown for us so much over the 20 years that I've been working at Surfrider. And almost all of those 60 labs, maybe 10 do not rely on partner power. So our Surfrider chapters are volunteer run. Most of them do not have physical space. We don't have offices out, for all of the chapters just in our headquarters in Southern California. So our chapters partner with other organizations, environmental groups, aquariums, universities, to set up our labs and either share responsibilities or just literally use that space. We have a lot of labs set up in high schools where a science teacher will oversee students processing samples, and adult volunteers from the chapter will collect samples and bring it to them. We also have some chapters that participate directly in beach monitoring programs run by state and local health agencies and other watershed groups. All of these labs are out testing for fecal indicator bacteria, almost unanimously the Enterococcus, because we're testing marine waters and coastal waters. We set up our sampling plans to complement those agency-run beach programs. We are filling in seasonal gaps. The agencies typically test during the summer swim season. We're out testing year-round, and we're testing anywhere that people are getting into the water, recreating, enjoying the water, as well as sources of pollution that could bring pollutants down to coastal recreational waters and beaches. This is just a sample of some of the sites that we test, sources of pollution in the summer, as well as throughout the year. All of our data is posted online at bwtf.surfrider.org, and we display our test results every time we test. Some chapters test weekly, some bi-weekly, some monthly, and the data is displayed relative to the beach action values or water quality criteria that are used in that state to issue swim advisories or open and close beaches. You can click on any of our sampling sites and pull up all of the past data that we have for any particular site. It's all freely available. In addition to the online posting, our chapters have gotten really savvy of getting their information out into their communities, sending out water quality emails after they test every time, doing posts on social media. And some of our chapters really have a big following locally. We don't just do water testing, we do beach cleanups, we do fun events. So people are really looking at us a lot for fun stuff to do out in these coastal communities. And then various ways of in-person communication of our program. This is just some examples of some social media posts that we have. I think this is North Carolina, Maui, and then down in Puerto Rico. Community outreach, we do tabling events at fairs and other type of community events, and then we will bring kids, typically it's kids, sometimes community members, to the beach and just do a demo of what we're doing, show what we're testing for, why that's important, and just get them engaged and realizing that water quality is a thing that they should actually be concerned about, not just checking the weather and the sun and the UV index and the waves, that also water quality is important. So if we look at the Maui Blue Water Task Force program, before the fires hit, they had a lab that was set up. They were sampling a bunch of sites on the North Shore there in the middle part of the island, and the Southern Shore. That's where most of our members were located. We had this lab at this community center in Paia, which is up on the North Shore. And then it moved over to the UH campus that's close to the North Shore as well. And then we also had a lab set up in Hana, this very remote area on the east end. Nobody else was testing there. This was a really great benefit for these high school kids to be able to generate really needed information for their community. The chapter was sending out testing monthly, sending out water quality emails, social media posts that were sometimes even picked up by the local newspaper every time they test. Hey, Surfrider went out and tested. This is what they found. So there was a good awareness of our program on the island. And then the fires hit, right? August 2023. I'm sure many of you watched that horror on the news. Like, it was incredible, right? It went through so quickly, really destroyed this beautiful historic town, city. Not only was all the vegetation and the buildings wiped out, but also you see all those boats that were in that harbor are no longer in that harbor. Now, our chapters are volunteer run. They're members of the community. We had some members who lost their home. Our vice chair, fortunately, was one of those lucky green pockets in the middle of a charred landscape. So our mission is protect and enjoy oceanways and beaches, but as community members, when something like that happens to your community, you want to help. So the first thing our volunteers did was just volunteer with other groups, right, that were giving that first response aid and assistance to people affected. But then as the fall went on and the cleanup process started, so after a fire like that, the EPA goes in phase 1 and removes hazardous material, lithium batteries types of stuff, and removes that from the site. And then FEMA or Army Corps goes in and does the phase 2 cleanup, which is the debris, scraping the ash off the topsoil, that type of thing. And in between those two phases, typically the homeowners can go in and just look and see what's there. Is there anything to salvage or not? But as this process was going on, a lot of environmental and access concerns emerged. There was a lot of people asking a lot of questions. There was a lot of involved agencies. Nobody really knew who to turn to for what. So this HUI, or sort of like council of community groups, formed to talk through some of these issues. Nonprofits, researchers from University of Hawaii, state agency members would come relatively regularly, as well as some of the feds, depending on what the topic was. Some of the first issues we dealt with was talking through strategies for preventing ash and debris from mobilizing out into the ocean. And there was some controversy there. These were some tough issues for the community to deal with and the agencies. And there was a lot of conversations about researchers planning and going after funding to really look at the impacts on the coral reefs long-term from how water quality might be impacted from these fires. But we were being asked, yes, but is it safe to swim? Can I go into the water? Most people realized right in the core area of the burn zone, it was not smart. You couldn't even get there. There was no access. But how far did that potential danger extend down the coast? You know, could we get in the water anywhere? And there was this really awful map that was being used. And for some reason, everybody just grabbed hold of it. And what this is showing is the grids that EPA and FEMA were using to complete their phase 1 and phase 2 cleanup, and go from red to yellow to green when EPA was done one and access changed, and then the access changed after the cleanup. But it had nothing to do with data at all, or safety. It was literally just access. And you can see some of these grids are actually in the ocean along the beach, and they would go from red to yellow to green, depending on what the adjacent land parcel cleanup was. And people are like, oh, that beach is open? Or like, I don't think it's open. So there's a lot of back and forth. And there was a lot of contaminant. There was testing being done with the ash and the soil and the air quality, and we were finding heavy metals and all sorts of like really nasty things that should not be in the water that people are in. Seawater samples were collected by the state, but there was an article in the paper a couple of times that said, we have samples, but we don't have the funding to process them yet, and it's probably going to be, I think they said 5 or 6 months before the results were released. And I'm like, that is ridiculous, right? We can do better than that. So we consulted a bunch of water quality experts. This is not our core strength. We test for fecal indicator bacteria, but it was like time for someone to step up. And actually, I know Ken Schiff from Squirp is here. We started by some of the experience that our partners had had in California to see what they had tested for post-fire and what their recommendations were. Talked with some folks in Hawaii. We had to consider who's testing for what already, where can we be helpful, what can we afford to do, and what can we feasibly collect and hold and ship properly to a lab in California for processing, because there was not a lab in Hawaii that could do this testing. So what we landed on was testing for heavy metals, the PAHs. We established sites for the enterococcus because we could do it, and then the turbidity and total suspended solids. We went out, remember the fires were in August. The first real heavy rain was in January, and we just barely got all our sampling gear ready to go out and capture. We went out the next day after this rain. There's a ton of brown water in the ocean off of Lahaina, everywhere in Hawaii, really. And we pulled our first samples. We did 6 sites right within the burn zone that are clustered there together, and a site further out. So if we did detect contaminants of concern, we wanted to see how far they extended down the coastline. When we got our results back, which ironically enough, it took, I think, a good 6 weeks, because after we collected our samples, California had this big atmospheric river bomb, if any of you heard of that, and all the labs got totally loaded backlogged with samples, but 6 weeks was better than 6 months. And so we got our results back, but then we had a challenge with interpreting it, right? With the fecal indicator bacteria. It's very clear. What is your concentration? Is it above the health standard? Is it below? Boom, that's your judgment for what it's worth, right? But there wasn't clear criteria in recreational water for these metals and PAHs and types of things. So we looked at the World Health Organization has screening levels for recreational water, which they've literally just taken drinking water and multiplied it by 20 and said, that sounds about right. And then we also looked at EPA aquatic life criteria, which we realized were probably more sensitive than what we needed for recreational exposure, but we thought that's one way we could compare it. The other challenge we had was having a good, relevant local seawater standard, because Hawaiian soils have a really high metal concentration, the volcanic soils that they are, and there wasn't a great one. There was one from further out into the ocean, but not in a coastal area. Despite all these challenges, with a lot of back and forth with a lot of our partners and agency and experts, we really concluded that we didn't see any significant human health concerns with our results. We didn't hardly find any PAHs anywhere. And that was consistent with what others were not finding as well. The fires burned so hot that I think those just sort of burned off. And then all of the metal concentrations were well below that World Health Organization criteria, as well as even the EPA aquatic life criteria, with the exception of copper at one site right in the middle of the town. We did a lot of back and forth with the Department of Health, looking at our data. They were comfortable with it, and we posted it on our website. And then something wonderful happened. They wanted to release their data because we released our data. So when we put our data up, it really motivated the university folks to release their data, as well as the state agency. And there was this shared press release. Hey, these 3 agencies have gone out, they've tested, they have not found, contaminants that put human health at risk. This might have been a little stronger word than we would have said as far as safety, but the Department of Health issued it. So we were just thrilled that we motivated them to come out with something. But we didn't want to just leave it at that. We wanted to go back out in dry conditions to see what the change might be. And we also established that standard. We went way around the corner there at this Fleming Beach. It's in a different watershed, yet the soil is very similar to what we would be seeing along the rest of Western Maui. We changed our sampling a little bit to be more representative. And in the end, we had the same low results. We only found copper at 2 sites right in the central area that barely had levels exceeding that chronic aquatic life criteria. So once again, we didn't find human health risks. So that was fantastic, actually. In addition to providing this information that was really needed on the island. We also accomplished some really great things here. We strengthened and improved relationships with other organizations working in this space on Maui. We have really good working relationships with other NGOs on West Maui now. And with the Department of Health, it's literally, we took a 180 turn with them. There has been a history of, we poke them a lot to do more, and working together through this, we really have a much more collaborative relationship there, which is so fantastic. We have those established sites on West Maui now for ongoing bacteria testing. There is now this great wildfire database that the Department of Health in Hawaii manages that shows all the different data in a pretty easy way to read now. So if any of you all are interested in this, I definitely recommend checking out that website. And as an organization, Surfrider now has some really valuable experience giving the growing risk of wildfires in a changing climate. And unfortunately, we're already sort of back at it in LA and working with our chapter there to try to figure out what's going on, who's testing for what. What does this red advisory mean? What does this yellow advisory mean? Can we get back into the water? So anyway, thank you. I want to thank the Maui Strong Fund of the Hawaii Community Foundation who supported most of this work. This is my email address and the website. You can learn about this program if you're interested at all.
Yeah, we do have time for questions at this point.
Yes.
So the copper exceedances one required for two in sort of more pristine area, I guess. Is that a geogenic source, a natural source, or is that sure it would be from humans or?
The copper, the two sites that were elevated for copper were both within the burn zone. The copper is the only metal that we and others detected above sort of natural levels once we had that that new reference. I think the evidence there is it's fire related. I don't know exactly. Again, this is not my core competency filling in, but that is the one that was like, okay, this is the one that seems elevated. Yeah, I mean, electrical wires were down, anything that's, I mean, commercial buildings burnt, boats burnt, people's homes burnt. Yes. Yes. Yes, absolutely. That's being done currently. There's a bunch of folks at UH that are looking at that. Specifically, the coral reef ecosystem was the big, like, what's going to happen to our reefs next year, in 5 years, 10 years? Is there going to be an impact? And if you contact me, there's a woman who just gave a great presentation showing her data from the last year and a half, I guess. On that, I could share with you. A lot of people were doing that, and that was sort of the whole point. Everyone was worried about, just take it for what it's worth. We're really worried about the ecosystem and the fish, and we're like, yeah, but what about people? Can people get it? Because that's what we want to know. So. Oh, from people eating the fish? I don't know, and that's a really good question. I know we're looking at coral reefs, but I could look at that. I know people who are doing that, but I don't know what the outcome of that is. That's a very good question, which I had sort of forgotten about. Good?
Yeah, I have one. Just from like a response, the next fire, like what do you really learn? Like, how would you do it differently in the next fire response?
We would have collected the reference the first time. And there was some miscommunication on total suspended solid. I thought we were collecting for total suspended solid and we didn't. So we had to look at some others, turbidity data and some visual assessments. I mean, next, The biggest challenge was, okay, we have data, now what are we gonna do with it? And looking at what we compare it to, so it's still not easy, but at least we have some steps forward on that. Yeah, and I think going into like the LA fires, having been through this already, there's a lot more capacity in LA to do all this testing, but there's still issues with communication and people not quite knowing what it means when the Department of Health says this or the state says this.
Yeah, we have time.
How common is historically are fires naturally? Or historic events going back, or prehistoric events, be something that the regions would adapt to?
I don't know how common wildfires are in Hawaii. However, what I do know is each island has a wet side and a dry side. And this was on the dry side. On top of that, there was a ton of land on Western Maui that over the last decade came out of sugarcane production, like thousands of acres that basically was allowed to go to weed. And there was just this very dry, invasive grass that was upland of the coastal area where most of the development was. So it was sort of it had been a very dry year. It was a very windy day. And it was just easy for that to ignite. And Hawaii wasn't ready for it. Their response was not ready for it by any means. I live on Eastern Long Island in the Hamptons. We just had a wildfire last week, right? We have an invasive beetle that's gone through and attacked our pine trees. So it's all this dead pine, dry tinder on Eastern Long Island. It's been a very dry year, and it was really, really windy last weekend. Something happened and it went up in flames. So I don't know how historically this has happened, but as humans, as we've changed and invasive species are coming in and changing our ecosystem, changing the resiliency of our ecosystem to deal with these types of conditions, I think it's going to be more and more problematic.
Good, yeah, thank you.
Yeah, so our next presenter will be Abby Heilman from the Isaac Walton League of America.
Hello, everyone. Thank you so much for being here today and listening to my talk. As Sean said, my name is Abby Heilman, and I work for the Isaac Walton League of America. For those of you who are unfamiliar with the Isaac Walton League, we're one of the oldest conservation organizations in the United States. We were founded in 1922 by a group of anglers looking to preserve habitats for future generations. And so we have a number of clean water programs. We also have a pretty strong agricultural program as well, trying to conserve habitats and resources for future generations. And Salt Watch is one of those clean water programs, and we're here to learn about that today. So every year in the United States, we use somewhere in the realm of 20 to 30 million tons of road salt on our sidewalks and parking lots and roadways every year. And we need to use the salt to stay safe, but we can be a little bit smarter about how much salt we actually use. So a question that I get asked a lot is really, what is road salt? And I'm going to be using road salt and the word chloride pretty interchangeably throughout this presentation, And hopefully this slide explains a little bit of why that is. So some of the typical de-icers that we apply on our roadways and sidewalks, de-icers, they help to melt that ice to keep us safe in the winter. So sodium chloride is one of the most common salts that we use. It's also the least expensive, which is probably why it's the most common, but also things are used like potassium chloride, magnesium chloride, and calcium chloride. And as you'll notice on this slide, all of those things contain chloride. And some of the salts also are mixtures between those different types of chlorides. Another question is, how is salt applied? And I think really understanding how some of the salt is applied really helps to understand sort of some of the issues that are going into the problem of over application of road salt and just some of the stakeholders who are involved, because there's so many different people. There's our applicators, there's people who are driving back and forth every day, there's insurance companies, there's people who hire those applicators, just so many different people involved in road salt. So it's applied typically in two different ways. The photo there on the left is showing a snowplow that's applying that granular rock salt, sort of those chunks of salt that we're pretty used to seeing. That salt is actually not one of the best practices anymore, but there is a time and place for that salt to be applied. Some of the cons for that granular rock salt application is, one, it's very concentrated. That is completely salt in those chunks. It tends to bounce off of the roadways and sidewalks as people are walking by, as it's being applied, as vehicles are going by as well. Best practice actually for road salt application is that photo there on the right where you see those lines that are on the roadway. That is called brine application or brine solution. It's still salt, but it's much less concentrated. It's a salt water mixture. So it's about 20% salt and then the rest is water. It's sprayed up until 24 hours in advance, or sorry, 48 hours in advance of a storm event. So it saves applicators time and money. It's much less concentrated, so they're applying a lot less of it to the roadways. It's creating a really nice barrier between the surface of the roadway and any precipitation that's coming down. So it makes it so applicators are really, it's easy to scrape off that any accumulation that comes down onto the roadways. And then it also doesn't bounce off as it's being applied. It's really sticky to the roadways. So that's one of the best application practices currently, but you cannot apply it when rain is in the forecast. That's the only downside. Just for reference, it only takes 1 teaspoon of salt to permanently pollute 5 gallons of water. We use the words permanently pollute here because once salt enters the environment, there's really no feasible way to remove it. It ends up in our soils, our groundwater, our waterways, and it really stays there for years to come. And it does have a number of different impacts from wildlife, infrastructure, drinking water, habitat, and pets, and many more things as well, but these are some of the things I'll go through here today. So with wildlife impacts, it does impact especially our freshwater aquatic life. They're not used to living in that salty water, and so especially smaller organisms like sort of phytoplankton and things like that, and Daphnia, they're usually more susceptible than larger organisms like fish and other organisms as well. Things like vernal pools, which are those seasonal waterways that are created with snow melt, those can be really intensely affected because there's no discharge point. And so if salt gets into those waterways, it doesn't really leave, it sticks around. And a lot of really sensitive organisms use those habitats to spawn, things like amphibians, which are probably migrating about this time right now. And then also migratory fish are not able to find spawning grounds as easily due to elevated salinity. There are a number of infrastructure impacts as well. So chloride in salt is really corrosive. It corrodes our vehicles, our pipes, our roadways, our bridges, concrete surfaces, different appliances, stormwater infrastructure, and so much more. There's an estimated damage cost. So for each ton of road salt applied, the salt itself costs about $78. The application of that salt costs about $270. But the damages that result from that salt can be up to $17,000 per ton. And that's pretty extreme, and that is with 2023 inflation. There's also a number of drinking water impacts too. So a lot of people don't think about where that salt goes once it's applied, and a lot of people might not even realize where they get their drinking water, which can be a big issue too. Most drinking water utilities, they don't have the funding or infrastructure to actually be able to remove that salt from the water. And so a lot of people who are on low sodium diets, low salt diets, they might not realize that they're getting additional salt in their drinking water. Another big issue too, if you remember back to 2014, that was the beginning of the Flint water crisis in Flint, Michigan. Road salt was actually one of the factors in the Flint water crisis. There's a number of things that went wrong. They switched their water source directly to the Flint River. It was April of that year. It was really high in chlorides from the road salting the winter prior. And they didn't put in the proper amount of anti-corrosives in the water. And so as there's pumping that water out to residents, it corroded the interior of their pipes, leading to that lead and copper in people's drinking water. And then also I wanted to mention too, well water is not regulated by the government. And so people might not be realizing that they have salt in their well water, which can corrode their appliances as well, since they're supposed to test that water themselves. There also are a number of habitat impacts, especially for plant matter that is near to sidewalks and roadways. It tends to be the most at risk. And there's a lot of different studies that are also being done too by some plants that might be able to uptake some salt, but also that people are realizing that chloride also mobilizes heavy metals in the environment too, which is certainly cause for concern. And of course, some people, they don't care about any of the other things that I mentioned, but they do care about their pets. So pets are something that can also certainly be impacted, especially folks who are walking their dogs outside during the winter time. So poisoning through ingestion, if they're licking their paws after walking on those salty surfaces, can cause some issues with our pets too. So part of our program is finding out what some of the people that we're talking to really care about and trying to find those things that connect to those folks. So pets is usually one of those things that if you don't care about the other thing, it's the pets. So our program started in 2017 when there was this huge road salt spill outside of our national office headquarters in Gaithersburg, Maryland. And at the time, we didn't really know who was responsible for this spill, but even more importantly, who was responsible for cleaning this up. So we called a number of different organizations. Was this the county? Was it the city? Was it the state? Was it a private applicator? Who's going to come take care of this? Finally, the salt spill was cleaned up, but we had actually been doing a long-term monitoring site sort of right below where the salt spill was. This spill was actually right on top of a storm drain that led to a local waterway right below the Muddy Branch, which leads into the Potomac River, which is a drinking water source for millions of people in Southern Maryland, Northern Virginia, and Washington, D.C. So the spill is cleaned up, but unfortunately, the chloride level spiked to almost 3 times the toxic limit set by the US EPA for aquatic life. So we launched our program then in 2018 with several goals to raise awareness in the general public about the connection between salt and stream health, to identify those hot spots in freshwater, and then also to advocate for smarter salt application as well. And as part of our program, we send out free test kits to anyone who's interested in getting involved in the program. And the test kits, you go to our website, saltwatch.org, you sign up for a test kit, and we mail a kit to the address that you provide for free. And each test kit comes with 4 test strips, instructions for how to take a sample, a conversion chart to convert the units of the test strips into chloride, and then information on how to upload that data online to our online database, the Clean Water Hub. Since our program began in 2018 until I think last week, we've received over 26,000 data points from across the country. And most of that is sort of in the northern Midwest and mid-Atlantic regions, as you can see here on the map. The larger the dot that you see, the more data that we've gotten in those regions. And then the colors of those dots correspond with what those chloride concentrations are. And since we are a nationwide program, I know that the levels of chloride can vary from state to state and region to region. And so that's sort of why we established the scale that we have. Anything below 30 parts per million is below the level that we can tell or really is indicated on our test strips. So we consider those samples to be excellent. Between 30 and 100 parts per million, we consider to be fair. Anything that's over 100 parts per million is considered to be anthropogenically caused. And then anything that is between 100 parts per million and 230 parts per million, we know that that's definitely elevated due to human activity, but it's below what is the chronic toxicity level set by the EPA, which is 230 parts per million, which is what we consider to be toxic. And we would not be able to do this without our SaltWatch partners. Nationwide, we have 71 SaltWatch partners, official SaltWatch partners, and over 600 organizations that are participating in our program. And what we really want to see from our program and have seen, and I actually have an asynchronous talk that talks about some of the case studies, so please feel free to check that out after this. We want people to take our data and we want them to turn it into some sort of action. And all of the things that you see here on the screen are some of those actions that people have taken. Opinion pieces in the Washington Post. We had one of our salt watchers in Philadelphia testify at the Philadelphia City Council about really high levels of salt that they were seeing. And we also have, there's a number of bills, various states across the nation that are trying to do road salt reduction practices as well. So we send out action alerts to people who sign up for those action alerts, which basically gives people a template letter that they can really easily send in to their legislators, both local and state level. And we do provide people with a number of different resources on our website, saltwatch.org, from fact sheets to flyers that they can hand out. We have a whole advocacy guide that goes through some talking points to different groups, whether it's your HOA, whether it's a private applicator, a public applicator, your neighbor, just talking to all of these different folks about smart salting practices and some easy steps that you can take and do at home to reduce road salt pollution. We also have a number of resources in Spanish, as well as template letters to the editor, template letters to your representatives as well. And toolkits too. So we recently realized that faith-based organizations do not like to be called businesses. So we made their own toolkits for faith-based communities. Our Isaac Walton League chapters, we have 200 chapters nationwide, so giving them some resources for really how to get involved in things that they can do. We also have an event toolkit for our Paint the Plow program, which is a really awesome program that really anyone can take this guide and use, team up with the Department of Transportation, have them maybe donate some plow blades for 2 weeks that you paint smart salt messaging on. We did this with 11 high schools and scout troops and water organizations in our local community. And then those plows can be seen servicing the streets throughout the winter with that smart salt messaging. So a really awesome billboard that also gets people involved with their local Department of Transportation too. And we're all about meeting people really where they are. So we've done a bunch of business outreach, literally going door to door to businesses, talking to their employees, making contact with some of those business owners, those property managers, trying to learn sort of, well, how did this winter go? What did you do? How do you apply salt? Do you shovel before you apply salt? Some of those questions. And then giving them some resources to learn not only how to save money, because again, salt is really, it's cheap, but it's really expensive in the long term, especially with the corrosive capacity of corroding sidewalks and things. So not only could they save money at the materials cost if they're not putting down like an inch of salt on the sidewalk, but they can also save money in the long term by protecting their investment of their property itself. We do a number of virtual webinars per year. We also table at farmers markets year round. We table at a number of different farmers markets just as a really easy avenue to reach more people, to hand out those free test kits, and to get people really more informed about what's happening in their own backyards. And then we're part of a number of different regional outreach work groups, one in Maryland, one in Virginia, and then there's one that just started in Pennsylvania a couple weeks ago. So really looking forward to that. And again, meeting people where they are, tabling events, no clean water, no good beer, at Oktoberfest events, trying to come up with some fun, creative messaging. We do a number of hikes where we team up with a local organization and we go on hikes. And we do water sampling and talk about smart salting practices, things like that. And then we have been offering free trainings to local road salt applicators and some of our city and county folks as well, trying to get them involved and learn about some of those best practices, because not everybody has that same knowledge base or access to information that especially our departments of transportation have. And just showing photos too is a really valuable way to really understand, oh, wow, like I am used to seeing this amount of salt on the sidewalk. Maybe that's not actually what we should be seeing out here, because there really is a lack of information out there. A lot of times there's no regulation on the bags, so they don't tell you how much salt to use, when to apply that salt. And it ends up looking like this. So trying to explain to people you really don't need that much. And in fact, more salt does not equal more melting. Salt needs space in order to work. That's why when you see those lines sprayed on the roadway, they're lines and not just all white. That salt needs space in order to work. And just giving them sort of a visual of this is the pattern that you should see, that pattern there on the right. And with that too, really easy ways to reduce salt at home. Shovel early and often to clear those walkways before snow turns into ice. That's so easy. A lot of times that might be the only thing that you need to do, and you might not need to apply salt after that. Scattering salt, a 12-ounce mug, your typical coffee mug, if you fill that up, that actually holds enough salt to salt a 20-foot long driveway or 12 sidewalk squares, which is about, or 10 sidewalk squares, which is about 2 parking spaces. And then finally, a really simple step that you can do after a storm event has passed, or maybe you spilled a little bit too much salt, sweep that salt up, store it in a closed container, and you can use it during the next storm event. So really easy ways to prevent additional salt from going into the environment, keeping you safe, and saving money as well. So thank you so much for joining me today. Again, I do have an asynchronous talk that's recorded on Whova, so feel free to check that out because it has some additional case studies on it. If you have any questions, please feel free to visit saltwatch.org, email me as well, and if I have any time for questions, I'd be happy to answer those today. Thank you so much. Do you want to pick?
Yeah.
Okay.
Yeah, please repeat the question.
Yep. Yeah, that's a great question. So the question is for organizations that are participating in the testing, or even for individuals as well, how often is the testing taking place, and is it at the same sample location every year or multiple sample locations? It really depends on what capacity people have, and I think that's one of the beauties of this program. We ask that people go out if they have time to once a month and try to sample at the same location about the same time every month. So like the first Saturday of the month or whatever works for their schedule. And then sometimes additionally during the winter time, sort of after some of those winter storm events or some of the first thaws or rainstorms of the winter to see some of those spikes. But some people, they have taken that further and do multiple sample locations throughout the month. It really depends what people have capacity for. I didn't talk a lot about our online database, the Clean Water Hub, but it's set up so if you do have like one sample location that you've gone back to, it actually shows that data over time. And so I find that to be really valuable and sort of a selling point for people to especially keep going back to that sample location, because that's what we want to see is if things do change over time. And people can sample their drinking water too, is something that I didn't mention too. So even if they don't have a stream nearby, they can also sample their drinking water.
Thank you. That was very informative. Two questions for you. First of all, does your campaign include any information about alternatives to, your typical road salt? Because I know there are other options out there for neighboring roads. And then my second question is, do you do any like quality assurance for your test case that you do?
Yeah, so the first question was about if we explain to people or offer resources about what alternatives there are besides the chloride containing deicers that we mentioned. And then the second question was quality assurance for our test strips themselves. So to answer the first question, we're all about using less, because even if you transition to a different deicer or use something that is for traction like grit or sand, there still are best practices around that too, such as sweeping it up after the fact. So I think we do have a couple of blogs that explain some of the alternatives to the salts that we've talked about here today. But for all of those things, it's really being more mindful about how much salt that we do use. And then the other question again was about the quality assurance of our test strips themselves. As far as test strips go, they are very accurate. They're plus or minus 10% accuracy, which is pretty accurate for test strips. And we are currently working on creating a quality assurance plan for SaltWatch, since we're integrating that into the CMC, which if you're in Matthew's talk the other day, he talked about that a little bit too. Do we have time for?
Yeah, that's.
Okay.
Grace, how you put together your messaging for the faith-based groups, because I would suspect there's a lot more people that use canes and walkers that might be very especially concerned about tripping and falling.
Mm-hmm. Yeah, so the question was about the messaging for faith-based groups, and that there is concern about especially older folks who are using canes or sort of assisted walking devices being concerned about slips and falls during the winter time. And that is something that we're very conscious of for really all of our messaging, really using that proper amount of salt. That is really the best practice. We realize that a lot of people are nervous about going out in the winter time, and that's one of the reasons why a lot of salt is over applied, is because people are worried about liability, especially for businesses. And so it's very similar messaging for the faith-based organizations. The one organization that we worked with to create that toolkit, Interfaith Partners for the Chesapeake, which is based in the Chesapeake Bay watershed, they especially were talking mostly about sort of community gardens and things and how those would be impacted a lot by salt. But we definitely, I think, did have some information about safety in that. But you can download our toolkit online. It's free and available.
Yeah, maybe one more question.
Have you found success in your training of the applicators and give them some protection from that liability? Like they're doing it right.
Yeah, so the question is sort of protection from slips and falls for our applicators and sort of how they're doing it. And how our training works. So for our training that we've been doing, we've been contracting that with Bolton and Menk, who runs the Minnesota pollution control training, and who everybody's sort of stolen their training program to make their own state training programs. One of the problems that we've come across, especially with those trainings, it's great information. It's awesome. We love people getting involved, but a lot of the times some organizations are limited in updating or upgrading their equipment. And so they are sort of, they might not be able to get brine application equipment. And so that's something that is sort of a downside to those applicator trainings. It'd be great if there's more incentives for that. There is something that has been sort of a push at multiple states, Minnesota, Wisconsin, Vermont, and New Hampshire. New Hampshire is currently the only state in the US that has a bill that passed at the state level that offers limited liability protection to applicators against slips and falls and the people who hire them, for applicators who take and pass a state certification training, maintain those best practices, maintain really detailed records and notes of the weather conditions and how much salt they're applying. And then those folks are offered limited liability protection as long as they're following those best practices. For the trainings that we provide and that our state and Maryland has been providing, we still recommend people are using those best practices and keeping those really detailed records, because if they do have some sort of issue with slips and falls, then they can have all of that data backing it up. And then hopefully more states will be getting the bills passed that'll help with limited liability at the state level. It's a great question.
Yeah, I'm glad you mentioned liability. I think that's a really big piece of this chloride issue, and So, yeah, let's give a round of applause. For
Okay, so our final speaker for this session will be Rayanne Eifert with the Wisconsin Department of Natural Resources.
Good morning, everyone. As Sean mentioned, I am Rayanne Eifert. I'm Lake Michigan Monitoring and Sediment Coordinator with the Wisconsin DNR. And today I'm going to be talking about a large data set we compiled starting in 2023 through 2024. This is our first real look at it, so I will caution we have not pulled the full data set together, but we'll be talking about how we're looking at PFAS in Lake Michigan's coastline and how that's affecting our food web. I'm going to start here because it's important, one, to know what this project is, but I think more importantly, what it's not. So we are not looking at hotspots. We're not targeting harbors. We are purposely looking at our nearshore background zones. As an agency, we need to know what the background is before we do anything at our hotspots. PFAS is everywhere. We want to go and look at harbors and understand what that means in context of the nearshore zone. We need to understand what the nearshore zone is. So to do that, we targeted our 10-meter contour along Lake Michigan. I'll show a map on the next slide. But for some of you, obviously we're not all local Wisconsinites here. 10-meter contour, that's actually about a mile out for a lot of locations along our nearshore zone. So we're not really at the river mouths. We purposely didn't target that because we have other federal partners who are looking at it. So USGS did a lot of work on our harbors and understanding what PFAS is in there in various locations. EPA does a lot of work in the offshore region. So we focused on the nearshore region. And eventually we're hopeful to put those various efforts together to really understand what's going on. And then we're looking at various trophic levels here because obviously we want to understand how these compounds are moving through our food web. Today, I'm just going to be talking about the plankton and mussel results. We don't have the fish and bald eagle here today. That'll be a future talk from someone else, but we can always start there. As far as sites and media, so we targeted 32 different locations along our nearshore region. At each of these locations, we did collect water. We collected water for 3 different events. So that would be spring, early summer, and late summer. We were successful at collecting surface sediments at 18 sites. We did our plankton study is really a pilot to see if it was worth the effort of doing additional plankton samples. Is it accumulating in those species? And then at mussels, we were able to collect them at 23 sites. We have no shortage of quagga and zebra mussels in Lake Michigan. They're fairly easy to find. So they are a pretty good indicator for those areas for contaminants as filter feeders. All of our samples were analyzed by our Wisconsin State Lab of Hygiene. They have, using their isotope dilution method, and through that method, they do report 33 different compounds for PFAS. I'll just mention here all the blinks on our word non-detect. It's really boring to talk about it. I'm not going to talk about it again. We did do equipment blinks. We did do field blinks. They're good. I can show you if you really want. Before we go into the data, it is important to put in context of what we have for regulations for surface waters in Wisconsin. We do have surface water criteria for PFAS, specifically for PFOS, which is bioaccumulative, and then PFOA. So for PFOS, that is 8 nanograms per liter in our water bodies, and that's related to when we would expect a fish consumption advisory. So that's like our first screening level of, is this water body likely impaired due to this, and is that having some sort of effect? For PFOA, it's 20 nanograms per liter for all drinking water bodies. A lot of people get their water from Lake Michigan, so that does apply here. And as a state regulation agency, those are the first things we look at with data sets. I mentioned we are pretty far offshore. We're about a mile off. We're not near any harbors. We do not expect that we would have had any samples above that criteria because it's just a lot of water diluting there. If we did, that would have been very concerning, but we didn't hit any of those criteria. Also important to note, there was no significant difference between our 3 different events for PFOS based off of one-way ANOVA. You might notice here, there's this one site in Green Bay, that lower Green Bay. That's where we kind of are today. You see that pretty green one all the way on your right. That site is our highest location for PFAS and it is the highest location for PFOA. It is our closest nearshore site to an actual harbor, and it is our shallowest site. So keep that in mind when we're looking at these things. All the other ones are along the 10-meter contour, but that area in Lower Green Bay is really shallow, so that one's closer to 3 meters. So I mentioned, no surprise, same for PFOA. Really low compared to our surface water criteria standard, but we do have that one site in Lower Green Bay that is a little bit elevated compared to the other locations. And we didn't see any seasonal differences for this compound. Now, as I mentioned, that's our first look and probably the most boring look we took at the surface water data. It's more interesting when you actually look at the overall profiles. And I'll try my best to orient you spatially because this is a busy graph. Here in the green box, that's Green Bay, those are those samples. We have the northern Lake Michigan in the next set of box, middle, and then the southern portions. Unfortunately, I added 2 sites after I created the others, so those numbering systems, when I put it in, did not line up. Those correspond with LM23s in middle, and then 24 is actually in northern Lake Michigan. So I do apologize that it's not perfect spatial representation. Some key things we'll notice are those carboxylic acid groups. So those are the top compounds that are listed there. They're pretty consistent throughout the profile. So that's your PFBA, your PFEA, PFHX, so on, so on. Those ones are fairly consistent throughout all of these. There are a few ones that are different in the various sites. So we have PFNA that seems to pop off at some locations, but not really in Middle Lake Michigan. The other ones that'll stick out to you is 6,2-FTS. That's related compound to our AFFF applications. We do have some locations that have that hit in this nearshore region, mainly Green Bay. One location in Middle Lake Michigan, and then there seems to be a cluster in Southern Lake Michigan. And then the other compounds that'll pop out maybe are at the ones at the bottom, that is the PFOSA and then the ethyl fossa. Those again are clustered in Green Bay and then a little bit in Southern Lake Michigan. Now this will make more sense if we actually do the cluster analysis, but I wanted to talk through what those profiles looked like before I just showed this complicated graph. So what we did is we did a principal component analysis of those 3 different sample events, and then we scaled that by the standard deviation, or set all or non text to have the detection limit, and dropped our duplicates. Now these results are put in 2 different ways. For those who do not want to squint at the graph to understand where they fell relative to each other, just look at the nice map. Key point here is Green Bay is very distinct compared to actual Lake Michigan, and that one Green Bay shallow site that I pointed out before kind of lives in a world of its own compared to the other data sets that we have here. We also don't, the Lake Michigan sites did themselves, so Lake Michigan coastline compared to Green Bay, did cluster a little bit differently compared to each other. It seems like the northern sites and southern sites are more similar than those middle Lake Michigan sites. As I mentioned on that previous slide, that's the one that doesn't have that PFNA hit. We also got those 2 sites there in red in southern Lake Michigan that are different from others. Those actually straddle a known tributary that is a source for PFAS. So not super surprising there. But our biggest takeaway is Green Bay is different than Lake Michigan. And that becomes more apparent when we look at the other media. We look at mussels. You can see those colors for Green Bay are way different than actual Lake Michigan. For the majority of Lake Michigan samples and mussels, PFOS is our largest component of the actual profile. It's not the same for Green Bay, and you'll notice there's a couple weird ones in Lake Michigan that are different, where PFBA is actually higher than PFOS. Those 3 sites in Lake Michigan, again, apologize for the numbering, those are just north of Manitowoc. So if you look at the maps, that's the LM10, 09, and 24, they're clustered right there near Manitowoc. The Green Bay sites, they actually have this strong PFOSA and ethyl fossa hit, which is different than Lake Michigan, and we don't have as strong of PFOS component in these mussels. So what's going on in Green Bay is very different than what's going on in nearshore Lake Michigan. That is also evident in the sediment, not just one media, all media. Some things you're going to note here, there's some hot spots in Lake Michigan. They're not really hot spots. So the vast majority of our samples are sand because it is the nearshore region. We're not targeting harbors where we get more deposition of that silty material. So a lot of these samples are actually coarser grain material, which makes those two jumps on Lake Michigan does not mean that's a hot spot. Those are just two areas where we had siltier material accumulating. So they were around some bends and areas. So they wasn't just sand. For all the PFAS sample or all the Lake Michigan samples, the PFOS again is that dominant compound. But then you look at Green Bay and you notice that is not the same. So that Green Bay samples, we're really getting those fossa, ethyl fossa groupings popping up both in the sediment and in the mussels. All right, now I'm going to switch gears and talk about the plankton. Just because this is a trial method, we wanted to understand our lower food web. We wanted to understand, okay, we know we're getting detectable levels in fish. We know we're getting detectable levels in mussels. What does that mean for our lower food web? Like, is it accumulating there? Is that the vector that we're getting into these systems? Can we quantify it at the levels that are in plankton to understand where some of these hotspots would be? So to do that, we did a lot of plankton tows. So Green Bay is green and easy to get biomass, maybe 5 tows. Lake Michigan is extremely oligotrophic. So we only did 2 locations on Lake Michigan for plankton because it takes 20 to 25 tows to get enough biomass to even run the sample. So it's quite the commitment. And again, this is a pilot study to understand if this method is worth investing for Lake Michigan. So to do that, we do a bunch of tows, concentrate it, put it in this PFAS safe bottle, then we bring it back to the lab and we basically separate it on 2 different mesh sizes of plankton net material. One for zooplankton, which is our 243 micron, the other one for phytoplankton, which is a 63. Then we just, concentrate those down, send them to the state lab, hope for the best. For our results, phytoplankton was really inconsistent. In fact, all of our samples, except for this weird one that popped up in GBO3, which is not real. That's an artifact of some contamination at somewhere along the line. They were all either below detection or right at that limit of quantification. So it seems for phytoplankton, we're not getting it, at least at these locations, at a level where you can actually quantify the PFOS. The same isn't true for zooplankton. Results for PFOS, but you'll notice a couple weird things that we still need to check out. LM19, that ethyl fossa hit, probably not real. We'll need to filter that out, but it did seem like we were getting somewhat consistent results, at least for the PFOS compound. So for our lower food web, we are getting quantifiable results. And I will say, again, as I mentioned at the beginning, this is just our first look at this very massive data set to understand what's happening in Lake Michigan. There's a lot more work to do. As a state agency, again, we weren't expecting it to be above our standards, but it is always comforting when we get things below our health standards for all of our sites. We do need to do some work on why Green Bay and Lake Michigan themselves are so different across all the media. So that does indicate different sources impacting those areas. But we were able to detect it in all of the media that we were working on today, except for the phytoplankton. It just seems like it's too low in Lake Michigan in this region to get it in that phytoplankton. We have other lakes where we've trialed this method, like Mendota. Dr. Patrick Gorski did it, and he was able to get some quantifiable results. It just depends on what the background PFAS is. So we probably won't be investing more time, I think, in phytoplankton for PFAS unless detection limits go even lower than they are, but they are still remarkably low at our labs. So for next steps, we do have isotope data, we have the eagle fish data, we also have water quality data along with these sites. So we have nutrients, we have alkalinity, we have the sod profiles, the vertical structures. There's just a lot here that we're going to be teasing apart over the next year plus. So we do anticipate having more conversations about this data set and what it means for those on Lake Michigan and looking at those co-located parameters. We also have sites that have all those media within one site. So we need to break that down in terms of, okay, at this site, we see this in the water, we see this in the sediment, this was in the plankton, equated to this in the mussels, up the chain. So once we start piecing all these things together, I think we'll understand for Lake Michigan at least where things are accumulating in the trophic level, and then we can further understand those other impacts. I have a lot of thank yous because we needed a lot of ship time. That's a lot of samples. For those who don't know, to go up and down the shoreline on one of these ships, that takes us a week to do one of those surveys for just the water. So we're living on and off the ships. So do need to thank the crew, the RV Niske, the crew of our research vessel with the DNR, that's the Corgonus, that's our fisheries vessel. My two summer helpers that braved a few waves and some other seasick days to make sure we could get this data set. So that's Jack Tyler and Cole Coffrin, the State Lab Hygiene, and of course, our funding source, which is the Great Lakes Restoration Initiative. Before I take questions, I want to point out one thing for Wisconsin. So Wisconsin, we do post all of our surface water PFOA and PFOS results on this data viewer. You can just look up Wisconsin PFOS data viewer and you can see it. So all of the surface water results we presented here and everything we've taken in the past year goes up there. It's updated roughly annually with things that were collected in the previous year. So if you are ever curious about what data sets exist in Wisconsin near your water body, I would check out there first, and then we would be happy to direct you if we know of another data set. With that, I will stop talking and let you guys ask questions.
Yeah, we have plenty of time for questions.
Do you plan on doing any mammalian testing, thinking like river otters,
No, so we're using the fish-eating birds, the bald eagles, as our first indicator for that. We don't have plans for mammal testing at this time. And that mammal testing for Lake Michigan, that would be primarily like harbors and rivers. The larger fish-eating birds would be more applicable to nearshore regions, even though they still eat in harbors and rivers.
I guess I have one. I mean, is there plans to revisit the sediment sampling, but stratify for silty substrates?
Yes, we do have a bit of associated parameters with the sediment. We do eventually hope to do some follow-up studies for the sediment themselves. As you can imagine, so I am the sediment coordinator, understanding what PFAS is in the sediment when we're evaluating dredge projects in the actual region zone, so we understand when a site is actually contaminated is important for us. Eventually we'll get there. We're just trying to understand it in general in Lake Michigan right now. I think we're probably a few years out for those follow-up studies.
Like in the sediments, like know the difference or like what?
Yeah. Yeah. Yeah, so the associated parameters we take with the sediments, we do organic carbon, we do grain size analysis, and we do the sediment pH for the sediment itself to understand the different composition of that between the sites. Yeah.
For those of us who might not be as familiar with the differences between that list of PFAS that we're testing for, is there anything more descriptive you could share with the difference of the types of PFAS you're finding in Green Bay versus the other area?
Yeah,
Where they come, anything at all?
let me go back to that. Yeah, no, I should have put the groupings. So like, yeah, these are individual compounds, but they're basically like your carboxylic acid groups, you get the ethyl phos groups, and they're just different sources by the groupings. So those gray ones at the bottom, those are your ethyl fosa groups. So it's a different group of PFAS compounds from a different industry, compared to just generally what we're seeing on Lake Michigan. I can get very complicated very quickly. Yeah.
You know, not to make it become more complicated, but I had a question along the same lines. And so are those then, these different families associated with any specific types of industry?
Yeah, there's a lot of work looking at those. Yeah, so it's asking if the different groupings are associated with different industries. There's a lot of work doing source tracking with PFAS based off the profiles. That's what we would like to do, get to the point where if we have something weird hit in an area, like if we have a greater proportion of PFBA compared to PFOS, like what does that mean for that source? The research is really breaking out right now on that. We are targeting for Wisconsin, really trying to understand our industries that are really active with discharge and what those profiles are like. So we are looking at things like, I don't know, you guys probably know we have paper from that panel talk the other day. We have a massive paper industry. What does that mean for these things? And going through those various industries until we understand what these mean in terms of actual impact. We also know Lake Michigan's massive. So we have atmospheric deposition, and understanding that background is another part of this. So we got the atmospheric deposition, the input from the rivers, and then specific industries. So you have to tease all that apart to understand where that impact is coming from. And we are a long way away from that.
Any other questions?
Either one.
You know, any plans, like maybe the Michigan GNR to do a Michigan shoreline, or if there are similar studies of this, being talked about or done, other Great Lakes?
Yeah, so I know Michigan does have their own, so the Michigan has their own PFAS team. They have, like, if you go to their website, they have a PFAS water research team. You can look up what they're doing currently. Obviously, I work for Wisconsin DNR, so I do not know what other states are doing, except for when I go to the talks. I only have jurisdiction over that line. That's why it ends at our state line. Yes.
Basically, a simple question is, what sort of resources are available? You said you have your funding through JLRI. Does that mean that when that's finished, you don't have the ability to continue this kind of work, or is it something the state will repeat that?
Yeah. The question was on funding sources for continued work on PFAS to understand it and its impacts and then address those issues. That is a hard question to answer in this environment, as you can likely know. Like, my job is actually fully funded by the Great Lakes Restoration Initiative at the state. So we're trying to understand what that means for all of our projects we currently have in-house and what we're going to be able to do. This project was already allocated. It was a short window grant to just do this baseline work to understand where it's accumulating in these various trophic levels. So that grant will end in, I think we have another couple of years to get this written up and finish it. We do have state priorities though with PFAS. If we don't have the Great Lakes Restoration Initiative, essentially our sites go into the full state list that we have for PFAS, and then we have to prioritize where we're putting our state funding towards, which you can imagine is a much smaller bucket than GLRI. So, yeah. Mm-hmm.
But like after that, there's not a lot of money to go around. Like fish examples, sometimes $1,
Yeah, each of our water samples through $350 a sample. So like these projects it's not sustainable for states to take on that level of research. We were only able to do this for Lake Michigan because of GLRI.
Yeah, thanks, Rhea. Yeah, and we do, if anyone has additional questions for the other speakers, we do have a few minutes here. Otherwise, yeah, look at those asynchronous talks, and yeah, we'll reconvene and after the break.
I don't think our. I think we're.